So in this question, we're supposed to solve this system of equations, and I have the answers revealed here, but let's talk about how I would get to those answers if I didn't already know them. The directions down below the answer fields reads, enter your answers as integers or as reduced fractions in the form a over b. If there is no solution, type DNE in each blank. If there are an infinite number of solutions, specify their form in the blanks in terms of x. Okay, now when I go to solve this system, what I see is that y is solved, or that the second equation is solved for y, rather. Okay, so because that second equation is solved for y, I can rewrite it, replace the y in the equation with the expression that is equivalent to y. So I'm going to take 8x minus 4 times y equals negative 8. And instead of having the y there, I'm going to take this expression, which is equivalent to y, and plug it in where we see the y here in the second equation. So I'm just going to erase that y and put in the expression 2x plus 2. Then I have 8x. That nothing happened to that first term, but negative 4 times 2x gives me negative 8x. Then negative 4 times positive 2 gives me negative 8. And on the other side, I have just the lonely negative 8. Now, anytime you see the same thing on each side of the equation, it will cancel out because, as you can see, if I add 8 to both sides, then both of those negative 8s cancel to 0 or 0 out. And then I have 8x minus 8x is equal to 0. Now, if I add, if I were to subtract, I would get 0. 8x minus 8x is 0, right? So now I have the expression 0 equals 0, which is a statement that is always true, okay? Now, notice that all of the variables disappeared, and then I ended up with a statement with just regular numbers in it that is true no matter what. So when this happens, it is because there are infinitely many solutions that will work. Okay, so what we're going to do is we're going to talk about all the many possible solutions in terms of x, because that's what we were directed to do. So what does that really mean? That just means that all your answers for both of the spaces provided, should only have the variable x in them and no y's in them. Okay, so we can see what y is, because in terms of x, that is, because it says right here in the first equation that y is equal to 2x plus 2. So the 2x plus 2 expression is an equivalent expression to y, but it's stated only in terms of x. So we actually see that that is the y coordinate, is the expression 2x plus 2. So that means that it allows for y to be many, many things, but always based on whatever x is, right? So then x is just x. So when it's in terms, whatever it says it's in terms of is what you're going to see. If it says in terms of x, then the x coordinate will be just the variable x. It won't be a number, it'll just be itself, the variable name. And if it says in terms of y, then of course it would be the other way around. You would see the y here. So let's do another example so that you can see this again. And actually, before we move on, I just remembered I want to point out something else too that might help you understand why this is occurring, or how this happens. We have 8x minus 4y equals negative 8. That was the first equation. If I reduce this by, because you can see each term is divisible by 4, so if I divide everything by 4, then I get an equivalent equation. 8x divided by 4 is 2x. Negative 4 divided by 4 is negative 1 times y, so it's negative y. And then negative 8 divided by 4 is negative 2. Then if I solve this for y so that it matches the same format of my second equation, because notice in the second equation it was solved for y, right? So I'm going to see what happens if I solve this for y. I'm going to subtract 2x from each side, right? So let's subtract 2x from each side. And then I'll have negative y equals negative 2 minus 2x, or you can write that as negative 2x minus 2. Okay, and then you have this negative y left here. Well, we want a positive y there, so let's divide everything by a negative 1. And all this is going to do essentially is change all the signs of every single term. So the negative y instead becomes a positive y. The negative 2x becomes a positive 2x. And the negative 2 becomes a positive 2. Now, if you notice, this, which came from equation 1, right? This is equation 1 right here. And we just played with equation 1 until it looked like equation 2. So this is one of those special cases where the two equations that are given in the system are actually the same equation. Um, kind of tricky, right? So what this means is that when you graph this line, or these two lines, you graph one line and then you go to graph the other line and it actually lays perfectly on top of the other line. So that means that they share every single possible point. And it doesn't mean that just any point works. It means that only points on that particular line works. So only if we were to graph this out, we would see that only x and y values that satisfy this equation would land on the line. And so only those ordered pairs are solutions to the system of equations. However, because there is an infinite line that has another of the same infinite line on top of it, these two equations agree everywhere for every single possible point, infinitely many points. I feel like I'm talking in circles at this point. So let's look at another example and hopefully it'll start to come crystallize a little more. Okay, here's my new example. And you can see that it has changed a couple of ways, but one of the big things that we want to notice is that it says to give your answers in terms of y, whereas the last example said in terms of x. So that means that if, in fact, these two equations turn out to simplify to the same thing, then we will have y in terms of y will be the answer for the first box, or I meant to say the second box, and then whatever the relationship is between x and y will be expressed in the second box, only involving y. So in other words, you solve for x. Well, if you notice, this thing is actually already solved for x right here. And so it's saying, it's giving us the answer right here, actually, um, like that. Yeah. So that doesn't happen every single time you see a question that has these kind of directions to it, but often it can happen. So what you want to do is just double check before you assume that this is what you're supposed to put in those boxes. Before you just memorize a pattern, try to understand what this actually means so that if you have a more complex example, that you would know how to handle it. Okay, so we're going to take the second equation. I'm going to show you two different ways of handling this. The first thing is I'm going to take that first equation, the first equation, and I'm going to see what happens if I divide everything by 4. Actually, I'll divide everything by negative 4. So then I'll have x plus 4y equals 4. Okay, so now I will solve this for x by subtracting 4y from each side. So I'm going to have x equals negative 4y plus 4. Okay, and now that matches the second equation. So because it matches, I'm like, oh, it's the same line, so it's infinitely many possibilities. It said to do it in terms of y, so I put a y here, and then x is solved right here in this version of the equation, so conveniently this expression can be used in place of the x variable, right? So it's almost too easy once you understand what's really happening. Um, Another way to see this is you can do what we did on the previous question before I explained that they were really actually the same equation. You can plug, substitute. I mean, this is typically what we do. If you don't notice that something is going to divide everywhere and reduce the entire equation, sometimes you end up solving like the old-fashioned substitution method. So I'm going to take my first equation and leave space for the x's because I see that my second equation is solved for x, which means that I can get rid of the x variable in my first equation by using this to replace the x. So that's always useful. If you can get rid of a variable, then it's solvable, right? Because you can't solve something that has more than one unknown in it, but if there is only one unknown, then you can eventually get that one unknown all by itself. So now I'm going to simplify. Negative 4 times negative 4y is positive 16y. Negative 4 times positive 4 is negative 16. Negative 16y, I'll just bring that down and then bring down this as well. All right, now we see this positive 16y and negative 16y will combine to be 0, and then we have negative 16 equals negative 16. Well, this is that case that I mentioned before where all of the variables completely disappeared and we are left with a statement that has only numbers in it and it is always true. So this is one of those dependent systems that always, or that has infinitely many solutions. Dependent and infinitely many, it's a dependent system and it has infinitely many solutions. Okay, it doesn't mean you can just write infinity. It means you have to state the relationship between the variables. So that is why we're saying that there's infinitely many points, but we can't give you a list of those points because it's infinite. But what we can tell you is that whatever y is, if you multiply y by negative 4 and then add 4, you'll get the x value. It's just a relationship. Okay?